Hello YouTube. Today we're going to be talking about something that is a little bit different and a little bit more complicated than what we've gone over before. And I know that some of you that may scare because I haven't done a great job of explaining things so far, but several of my teams, two of them have gotten this program and been able to modify it themselves and change it and work on it in a beneficial way. Now, So it is inside your grasp if you try and pay attention. And I'll go only as fast as I feel I need to. Now imagine that you wanted to be able to get people who are maybe a little scared of the programming environment in on the programming. And anybody can type down things like move forward at 100% power for 2 rotations, right? And then on the next line you could just put turn left 90 degrees, move forward at 100% power for 2.5 rotations, and for example this could be the beginning of getting the pink bacteria. One of our teams has a robot that if you were to run a program that realized what I had typed out here, that would actually grab the pink bacteria. Not get it back to base or anything, but that would work. So let's see if we can design a program that does that. And it turns out that we can, and it's actually a lot easier and a lot more elegant than you would think. Because previous programs have been huge and monolithic and very nasty. I mean, you couldn't see all of them at once. And this one, you actually can see all at once. This is a single my block that allows me to parse, to read, and to make intelligible commands that I've written down in a text file. Now, I'm not going to be able to type them in plain English like I just did. I'm going to have to type them a little bit separately, so it'll look something like move forward 100% power for 2 rotations, and, things like that. But that's still, a pretty good little interface you can have. And you can actually expand upon it and make it as complicated or as simple as you want. So what we're going to do is we're going to look at this block we have here, which is the file block. Now the file access block has quite a lot going on. If I drag one over here, this block. I must be crazy today. If you look at the file access block, you'll see that it has 4 different actions: read, write, close, and delete. You notice you can close it, but it never tells you can read it. Well, it turns out that whenever you try and read or write to a file, it automatically opens it. So if you can automatically open, why don't you automatically close? Well, let's say that you wanted to read the first 3 lines of it, and then read the first line again. You would put down 3 read blocks, and then you'd have to close that file before you went over and read from it again. Now, at the moment, this is going to read a text file that you assume is on your robot called my file. It's not actually on your robot, and this would do nothing. However, there is an easy way to get your own little text files from here onto your robot, and I'll show you that in a moment. What close is going to do is it's going to basically reset it. Every time you read a new line. Every time you write, you're adding a line at the very end of the text file. So closing allows you to start at the beginning. The other option is, of course, to delete, and that's not something we're going to do. And one quick word about the file access block. Under normal circumstances, this isn't a problem, but if you build a program in a specific way, you'll have to worry. You'll run into this problem I'm talking about. The memory inside your computer is of a certain type, and that type of inside your NXT is of a certain type, and if you try to write to it more than, I think it's about 10,000 times, it starts to fail. Now, that means anytime you change something on it, anytime you download a program, anytime you write to the file, anytime you do something like that, you're cutting down on the lifetime of that hardware in there. And that's okay. I mean, it's perfectly fine to use it. But what you don't want to do is you don't want to have a loop that, say, is constantly writing to a file. And then maybe in a worst case it's even deleting. So it's constantly writing and deleting, writing and deleting, and writing and deleting. That's bad. That can cause some significant problems. Seriously cut down your hardware's lifetime. Now this is only going to be reading from it. We're not going to be doing any writing to it. And depending upon how you look at it, this approach can even increase the lifetime of your hardware. So skipping all that, let's see if we can go into what's actually happening here before I continue with the video and we rebuild all of this. Now, this is a my block that I've made. I don't really have a good name for this program. Originally I did something kind of sort of similar, and I called it Smooth Move. That was back in 2009 when Smart Move was out. And now I just don't have a good name for the file, so I called it DBF, or Drive by File, in an allusion to fly-by-wire systems. Though I think a fileDriver or something may be more appropriate. Anyways, the my block gets a single input, which is file name. It's a text input, and we're going to save that into this variable here. I guess I could actually connect it directly to everything, but I kind of like using variables. It's closer to how my experiences with programming in languages other than this have been. Now, just to make sure that I don't accidentally have that file open, I'm going to close it once here at the start and once here at the end of the program. And as you see, that is all over here. I guess I could probably add another stop block at the end, just to tell the motors to cut it out. Now I'm going to write the value of false into this little variable, which is going to tell me, hey, the program's not done yet, keep doing all of this stuff. And this stuff I have highlighted here is the meat of the program. Now, this is a loop, and it is set to logic. So it's going to go until true, until my exit actually says, hey, let's exit out of this loop. Now, the name is going to be read. I'm going to read. The name is going to be read out of this variable here, which is going to be supplied to this file access block, and it's going to read from that file. Oh, and one other thing about these file blocks. If you drop them down, you'll see number, and you'll think, oh, that's the number that I read. Click. Not so. If you open it up all the way, you'll notice that the text out and number out are actually hidden. They're not open by default. And that is what you're going to want to get to. So, just be aware. So I make sure this is read text, because I'm going to want to read the type of command. Like, let's say I wanted to say move. And just because, I'm going to go ahead and display this to my screen, just because it's handy. Now this is going into a switch statement, and this may not look like a switch statement like what you've dealt with before, but if I pull down a switch statement, you'll see I can set it to a value. Okay? I can turn it between this flat view and a compact view. Now this is for logic, which is just true or false. There's nothing in between. And I can change it, however, to text. Now you'll notice here there's some grayed out buttons, but when I turn off flat view, this switch in here, this one gets ungrayed. I can add new conditions. So here I can have something called, say, move. It's going to do one thing when it gets some move. It's going to do another thing when it gets a turn. And it's going to do a third thing when it gets exit. And actually I'm going to add one more that I'm going to set as my default. By highlighting it and pressing the little star button here, that is going to be the default. If it's something it does not recognize, like let's say I gave it, instead of move, I gave it motor, in that case it would still get displayed to my screen, but once it got to here, it would just go directly to default. And you'll see that's indicated with the word default up here. In this case, this is exiting when it gets to anything it doesn't recognize, which is actually not the behavior I'm going to want to follow as this video progresses. So over here I have break, which just does the obvious, it breaks. Depending upon how you set up your program, you may not need a break. You may have breaks at the end of all of your other commands. I felt that it was a good idea to have a separate break. But I also have a tendency to overcomplicate things. So, exit is the default, and like I said, I'm not going to want exit to be the default in the future. Move, now here's where things get interesting. All I'm doing is I'm supplying the name of this file that I'm reading to a MyBlock. In this case it's called parse move. And all it's going to do is it's going to read these values, do some stuff, and plug them into my movement, and wait. This is not the easiest of examples, so let me go to wait instead and show you this. Here I'm passing the value of the file name to parse wait. And here the file name comes in, I read a number out, and that's going to tell me the amount of time. Now, this is measured in milliseconds, and it's not very nice and polite to have your programmer say 5500 if they want to wait for 5.5 seconds. So what you're going to have to do, not have to, but what you would want to do, is to simply multiply that value by 1000. And that's going to turn your seconds into milliseconds. So if you say wait 1, if you gave it a value like wait 1, then it is going to wait for 1 second, instead of waiting for 1 millisecond, which probably isn't what you wanted. Of course, in here I'm resetting the timer, getting the value out of the timer, comparing it against my time, checking to see if it's less than. When it is, that means it's gone over, and I exit the loop and I exit this MyBlock, which means I go back to my right here. I check to see if this is exit, which it won't be, and I'll go back to the beginning and do the whole thing over and over again. That may have all been very confusing, and that's okay if it was. We're going to slow down and look at it in a different form.